So here we are going to be classifying different triangles by either their sides or their angles. We're given triangles on the coordinate grid, so we're going to be using that information to help us out. First things first, so we got AB as 1, 2, 3, 4, 5, 6. And for AC and BC, okay, if I take a look at this, I'm going from C up to this point right here. 1, 2, 3, okay? And then if I go right, I go 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do the same thing for BC. I'm going to go down 1, 2, 3. Interesting. We write 1, 2, 3, 4, 5, 6, 7, 8. I have the exact same type of triangle, okay? My sides are going to be the same. So when I do Pythagorean theorem, and we have right triangles here, so when I do Pythagorean theorem, these two lengths have to be congruent. They have to. There's no ifs, ands, buts about it. So I don't have to do a whole bunch of Pythagorean theorem. I do need to find out if these are equilateral triangles. It's at least isosceles. In order to find out if it's going to be equilateral, I need to do my Pythagorean theorem. Doesn't matter which one. 3 squared plus 8 squared equals c squared. So we have 9 plus 8 squared is going to be 64 equals c squared. 8 times 8, yep. Plus 9 equals 73 equals c squared. And I'm going to go out on a limb and say square root of 73 is not a very nice number. And of course, it is not. Because of that, it is different than 6. Therefore, this has to be isosceles. It cannot be a right triangle. Okay. Now, this one, okay, classifying it by its sides, we have 1, 2, 1, 2, 3, 4, 5, 6. We have, that's going to be 6 down, 1, 2, 3, 4. So those triangles are going to be different. Okay. And then my final one, I've got 1, 2, 3, 4, 5, 6. Well, if that's 1, 2, 3, 4, 5, 6, okay, and my other triangles have 6 as a side, but when I plug it into Pythagorean theorem, it's going to be something different than 6, so they can't be equal to each other. So all of these sides have to be different. I can do the work if I want to, but I don't even have to, okay, because if AB is 6, BC has to be more than 6, and AC has to be more than both of them because 4 is bigger than 2. So I don't have to do all the work there if I think through critically the thought process in figuring out how to figure out these sides, okay? You think a little critically, you're going to be in a world ahead of where you want to be, okay? Now we're going by angles. So if I'm looking at these angles, okay, it first of all, angle A, 90 degrees would mean that C would be up at this point, and it is not. So that's not a right angle. Same thing here. And then C looks like the smallest angle, okay? So because it doesn't go to the right all the way, it doesn't have that squared off angle, everything is going to be less than 90 degrees. So this is going to be an acute triangle. Over here, okay, we've got to look at our slopes because I don't have, I mean, I know that this is going to be less than 90. I know that this is going to be less than 90. I'm not sure about B. So I've got to look at my slopes, okay? So if I'm going from B we'll go up here. I mean, they're all tracking the same way. I'm going up 1, 2, 3 over 2, up 1, 2, 3 over 2, up 1, 2, 3 over 2. So I'm going down to the right. So AB, the slope of AB is going to equal, we're going down and to the right. We're going down 3 over 2. And now for BC, we're going right here, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So for BC, we're going positive direction. We're going up 2 over 3. Well, those slopes look like they're opposite reciprocals. And if they're opposite reciprocals, we know that they are perpendicular. And if they're perpendicular, that means they meet at a right angle. Therefore, this is going to be a right triangle.